Hello and welcome to today's webinar, Secure Access Service Edge. Before we begin, there are a few housekeeping items to keep in mind. If you have any questions during today's webinar, please enter those questions at any time in the Ask a Question box below. We will monitor these questions throughout our webinar and answer them at the end of the webinar. You can download an industry analyst white paper on SASE and the slides from today's broadcast at any time by clicking on the Attachments tab. This webinar is also being recorded and will be available to view on demand following today's live broadcast. Now let's get started. My name is Michael Wood, CMO with Versa Networks. I'm joined today by Apurva Mehta, co-founder and CTO with Versa Networks, and Neil Danilovich, principal architect with Versa Networks. Welcome to the live broadcast, Apurva and Neil. We're looking forward to your presentation. Apurva, can you kick things off?
Yeah, thank you, Mike. And thank you all for joining. So I'm hoping that everyone and the extended families are in good health and safe. So today, Neil Danilovich and I would be presenting the mandatory and the optional requirements of SASE and some of the features which are expected of a good SASE solution. So I would like Neil to lead off with the presentation. Go ahead, Neil.
Thank you, sir, and thank you for everyone for coming in and participating in this webinar. As Apurva said, we will talk about SASE and kind of what makes up SASE. So, as we know, Gartner coined the term SASE, or the Secure Access Service Edge, in August of 2019, and this was to address sort of the transformation that was happening in enterprise networks across the world, right? And it really got accelerated due to the pandemic of COVID-19. As you can see here, many CIOs did not realize how many people would have to be working from home and what that would cause to the business. So if we look at what it was like previously, right, everything was funneled through the headquarters or a data center, and that's how you got access to your workflows. And then when things started to move to the internet, that still stayed as the hub and the anchor point for the network and connectivity, but provided a poor performance. So what was happening is people were transitioning to this idea that, you know, the user and the application experience was more important. So now what we need is the ability to work from anywhere, right? Work from home, work from Starbucks, and be able to have an optimal service that allows for access to SaaS applications, public internet, cloud forms, and also the enterprise data center. And what this means, though, is that our security posture has expanded immensely, right? I have to worry about securing the workloads and the users in different locations that I never had to worry about before. And I have to worry about how do I figure out that user experience. So SASE was developed to take into this whole kind of idea, right? Gartner said SASE isn't a new concept. It's just taking stuff and putting it together in a way that makes this a more secure access service. So it doesn't have to be a single vendor, but when it's not a single vendor, it absolutely positively has to be tightly coupled. And the reason for this is if you don't tightly couple it, two things happen. Either you have policy that's not properly instantiated in the appropriate security points, or you have increased latency or increased networking choke points that possibly could cause a poor user experience. When you think about a SASE service, it comes into basically four components. One is the networking aspect, right? We need a networking construct that is policy driven and application aware, meaning I'm able to identify things and then apply policy based upon users, based upon devices, based upon location, but also based upon individual applications, and then set performance metrics or SLA metrics to determine what the best and optimal secure path for that connectivity, as well as we need the security in it, because we're talking about secure. So I have to have security functions that need to be applied, and these security functions need to be complete. And we'll talk a little bit more about the security aspects in a little bit. The next part is it must be an elastic surface. Part of this is going to come into when we talk about the security functions, just the amount of compute that is needed to do some of these advanced security functions really requires the ability to scale in, scale out, create environments, if you will, to deal with threats. And the last part is really policy, right? It all must be policy driven. It needs to be funneled from a policy engine that allows this to happen at many points or at a single point, depending on what the enterprise looks at. So if we look at why policy is so important, is that when we talk about who needs to access what, the policy changes depending on what it is, right? So for an IoT machine, I might assume that I need to identify and authenticate the IoT device and deliver that traffic possibly to a cloud service or the enterprise, but I might not have to worry about that device or permit that device to actually go out to a social networking website. The same can be said of the employees, right? Depending on where they are, they might have different rights and different access to get to that. And then realistically, I need to be able to do this in a very flexible and modular manner, right? At some of my locations, I may have many of my security functions happening right on the premise. Maybe it's because I have a large campus networks, or I have a data center and I have all the compute there locally, so I want to do it there locally. Whereas in other locations, perhaps it is a traveling executive and he's in another country, and so minimal type of security is being done on a device that he carries or on the actual laptop that he uses, or maybe the mobile device that he uses, while the remainder of it is being done in the cloud. The key point, though, in both of these and in both of these models is that the same security policy and the same security functions are still being applied no matter which model you use, nor no matter where the individual user is. So we talked about networking, right? Networking is important. We have to have that policy aware, policy driven, and clearly SD-WAN fits into that, right? We're able to look at application flows. We're able to make decisions based upon different criteria and attributes that are given to in part of the application flow and from the user set. But SASE needs to go beyond that. And the question is why? Well, if you think about most services care about securing it inside the service. And SASE is extremely concerned about securing the end-to-end communication. So we have to worry about how the traffic from the user gets to your SASE service. And we have to worry about how do we secure the traffic when it leaves the SASE service to get to the end target or where the workload is. So that means we have to have security constructs that deal from end to end. So it's taking SD-WAN, taking security, and moving beyond that by tightly coupling them together in a way that makes it easy for the enterprise to instantiate policy and assure that the policy is uniformly applied. So next we're going to look at different security models of functions that need to go into it. And I'd like Apurva to take the rationale as to why a cloud access security broker is important to any SASE environment.
Yeah, so definitely CASB, the cloud access security broker, is one of the key components of CASB. And as you see at the bottom of this slide, that the CASB capability can be deployed in one or more ways or multiple ways. So one is the inline CASB. So there's a gateway in the path between the user and the secure access service, between a SaaS service. And then the traffic is brought to this gateway either through IPsec or GRE tunnel or based on a PAC file or a SASE client which is installed on a managed device. And if it is BYOD, then basically traffic is brought to a reverse proxy, which basically serves as a gateway. And the second mechanism is basically that is API integration using webhooks. So what happens is that the CASB basically it subscribes to all the APIs for the various SaaS services, and it basically then it makes all its decision based on that. And so, what are the key pillars of basically CASB? So the 4 key pillars are visibility, data security, compliance, and threat protection. So visibility means that the IT has to have complete visibility about the SaaS services which are being used by the various employees of corporation, and they should also know the risk rating and whether they are kosher, whether they are basically risky. And then basically it needs to enforce policy, based on the risk rating. And in any case, even if a particular SaaS service is basically safe, we need to ensure that basically no sensitive information is uploaded onto the SaaS service. So that's then we go on to the next piece here, which is the data security. So where basically the CASB needs to ensure that there is no misconfiguration, and there is basically no sensitive information is getting uploaded and made available to like unauthorized users. So so a CASB's job is to do encrypt and tokenization so that the sensitive information is kept private. And definitely it needs to be able to scan through basically images which are scanned, and it needs to do OCR on that and extract information and make sure that no sensitive information is being exposed to unauthorized users. And by compliance, it needs to basically again do API integration. It needs to a CASB solution should integrate with the API offered by the various SaaS services, and it should basically do remediation if something is by mistakenly exposed to a larger community. And it should have basically predefined policy templates, for various compliance regulations, like such as for PCI, HIPAA, and so it should make sure, that all the compliance, all the regulatory requirements are met. And lastly, basically the threat protection. It needs to make sure that that nothing basically nothing which is malicious being uploaded or downloaded. And also it needs to support definitely policies which are based on user group, device posture, content, geolocation, and all of these. So I'll let Neil cover some of the other basic other key features, components of the SaaS solution. So go ahead, Neil. Neil, you might be on mute.
So, thank you, sir. The next issue is data leak prevention. And as we all know, everybody is worried about the threats coming into the company, but clearly one of the biggest threats is information leaving the company, whether that's intellectual property that is being transmitted away from the company and possibly to a competitor, or whether that is sensitive information such as medical records, banking records, or credit card information. So we have to make sure that we do not let the data leak outside of the enterprise, especially the stuff that has been entrusted to the enterprise, in order for it to be safeguarded. As you can see in this model, and as Apurva talked about, there's sort of always 4 sort of overarching pillars, and one of which is compliance, right? We need to make sure that our policy is constantly in compliance. And we're going to talk about it later about how we do this, but the idea is SASE is not a set it and forget it type of security. It is not where you pass security and you're in. It is something that is monitored and is constantly monitored and making sure that you're in compliance at all times with the security posture for each one of these security functions. And then also each one of the functions also has its special set, which is what it needs to do. So in the case of DLP, not only do we want to possibly remove things, like, someone sends a social security number, maybe we just let the email go through, but we redact the social security number from it. Or maybe we do something that does like tokenization that automatically changes that number into something that's different so that it still goes through and somebody knows that a social security number was sent, but it's not the social security number. Or in the case of intellectual property, we might use a watermark, right? And so that we can actually stamp that as being the enterprise's actual intellectual property. So in this way, we're actually looking at everything, not just what's coming in and what could be malicious, but also what's going out and what could cause harm to the enterprise if it were to exit the enterprise unknowingly and unsuspectingly. Apurva, would you like to take the next?
Thank you. So another key component of basically SASE is remote browser isolation. So what is remote browser isolation? So remote browser isolation basically primarily tries to separate, a user from his real browsing activities. So a virtual browser runs on a distant node, which looks at malicious JavaScript or CSS scripts. And basically, this is mainly to protect the user and the company network from browser-based security exploits, as well as web-based threats such as ransomware or the malware. So browser isolation treats all websites and other web content that has not been explicitly whitelisted as untrusted, and it basically isolates them from the local device in a virtual environment by doing the real browsing in a container or a virtual machine. So that is what basically so remote browser is definitely one of the key components of a SASE solution. Neil, do you want to take the next one?
Sure. So the next one, as we sort of talked about as we were building this up from all of these sets, is that user and entity behavior analytics is absolutely a must for any type of SASE service. As we go through just trying to make sure that all threats and all threat actors are contained and not allowing anything malicious to happen to the enterprise or anything malicious or anything unexpected to actually leave the enterprise, what we need to do is actually monitor the behavior. At any moment, someone who works for the company, who has the proper credentials, who has the proper rights and permissions to actually get into systems, might actually just decide to do something untoward, right? It's just the way that we are. And, the news has been full of different examples of where that has happened. So this behavior analytics would look at the scenarios and build a database of information and run through many multiple scenarios to figure out the inputs from context and situation as to whether or not what someone was doing was proper or not, and then raise a security threat level about the situation and enable a SASE system to actually apply different policy based upon the situation that's happening. An example might be that, you have your normal engineering guy and, Monday through Friday, he's doing all his engineering work, and all of a sudden the system detects that the engineering individual is logging on Sunday at 2 a.m. and accessing HR or finance material. That might flag someone to say, hey, why is that happening, right? And what this also gives you is the model to constantly monitor, to constantly check. So you could institute, maybe it is a normal flow of business that that's what he would do, but maybe because it looks anomalous, you might change your security posture to actually send a multi-factor authentication to that user to make sure that it is the employee and not someone pretending to be the employee. And so in this way, you have this now analytics and machine learning and artificial intelligence that helps you figure out what is going on and how to actually apply different security postures in the system. Apurva, would you like to go next?
Yes. So again, another key component of a SASE solution is secure web gateway. So what is the job of a secure web gateway? Again, if we basically look at the main basically pillars, one is the identity management, like a next-gen firewall, malware detection, and proxy. So a secure web gateway should provide proper integration with the enterprises and identity management. So what it means is that it should basically integrate, if an enterprise is using Active Directory, then it should basically integrate with that. If somebody is using Kerberos, it should integrate with that. If somebody is using SAML or Radius or single sign-on, it should integrate with that. And definitely it needs to support multi-factor authentication. Then the next thing is basically it needs to support, it needs to be able to do contextual security. So it needs to be able to basically scrub the traffic based on user, group, URL, the reputation of the IP, basically the person is trying to visit. It needs to do DNS filtering. It needs to basically see if the device is authenticated and it is a managed device. And then what is the security posture of the device? Does it have the latest OS patches? And then definitely, what is the user and the group? Basically, who's the user and which group he belongs to. And also, basically, based on UEBA, has anything changed about his posture? And then it needs to basically scrub the traffic based on the application, as well as basically content. So it needs to do basically antivirus, DLP, next-gen IPS, and then malware sandboxing, file filtering, and all of those things. And a secure web gateway basically is a TLS, forward proxy or a reverse proxy. And so it basically does contextual security based on all these various parameters. Go ahead, Neil.
So as you can see, there's a lot of different security functions that need to actually compose and be part of a SASE service. And so the SASE service is going to do some of these things right at where the user is, and it's going to do some of these things in an actual cloud environment. And it's going to do that based upon the policies and what is dictated and what is needed based upon what the enterprise wishes their security posture to be. But what this means is I now have to have a distributed and globally defined cloud service, right? It is going to be very poor experience for a user in Asia if I always have to backhaul everything that I have back to the United States or back to Europe in order to get it processed, right? And I need to have it to be flexible so that I can work with different cloud service providers, cloud security providers, different use cases from a enterprise data center type of set. So that means that even though certain things might not necessarily work perfectly in every environment, the policies, the security is all defined and applied where it's needed and closest and most optimal secure path for it to be in that set. So in this way, having a global distribution of cloud gateways or SASE gateways will enable you to have a better user experience and a better security posture that is uniformly provided. Apurva, you want to show some examples of how this would be done?
Yeah. Yeah. So when you look at specific SASE topology and a SASE solution, so what does a good SASE solution should support? So first of all, it should basically support ubiquitous security, data privacy, and optimal traffic steering. So as Neil basically covered, during the initial basically requirements from Gartner, so SASE is a perfect marriage of networking and security. So SASE covers basically networking components such as path selection, routing, traffic conditioning, SAS acceleration, latency optimization. And then definitely it also covers a lot of security features like data leak prevention, threat prevention and detection, firewall as a service, zero trust network access, secure web gateway, obfuscation and RBI and UEBA. So all of these. So basically, definitely a good SASE solution should provide ubiquitous security, data privacy, and optimal traffic steering. And the SASE fabric needs to be elastic, and it should be able to scale in and scale out to provide the best user experience. And definitely, the SASE should provide basically it should optimally carry the traffic from either a SASE client or from a branch side to the SASE gateway. And so it should basically do SD-WAN or SD-WAN Lite between a branch and the SASE gateway, or basically it should do SD-WAN Lite between, for example, a SASE client which is on a mobile phone or on a laptop and the SASE gateway. Now, once the traffic hits the SASE gateway, it gets all scrubbed. And we would do full contextual security based on user group, location, device posture, application, and all of that. And after that, the traffic needs to be carried either to a SaaS service, such as a Box, a Gmail, Office, or it can be a web app, which is in a private data center. So basically, the traffic should be carried again optimally, between a SASE gateway and a private data center or the SASE applications. So again, it is very important that the traffic is brought into the SASE gateway optimally, and the SASE gateway processes it. And then again, from the SASE gateway to the SaaS services or the enterprise data centers or the cloud service providers where the private apps are hosted, again, we carry the traffic optimally. And definitely a SASE gateway should always basically provide the most optimal path to a SaaS service, irrespective of where a SASE client or a router which is sitting at a branch site is attached to them. Even if a branch site, irrespective of which gateway a branch router or a SASE client attaches to.
Do you have an example of this, sir?
Yeah. So let me cover this as part of this example. So what happens is that basically, so this particularly shows a SaaS service which is being offered globally by a SASE provider rather, and basically, definitely for various reasons, like any particular company, like such as Acme, it might have concentration of its employees, or his partners and all of them, let's say within the United States. For this example, we'll assume, that Acme Corporation is mainly a US-based corporation, and all the employees and basically partners and anybody else who interface with them are mainly located within the United States. So basically, Acme would identify, some number of home gateways within the United States where basically Acme is permanently instantiated. And what would happen is, so now when an employee of Acme basically he's like working from home or working from while traveling, then it basically would attach him to a SASE gateway, basically to the most optimal SASE gateway. And now what would happen is that all his traffic, basically would get scrubbed, would get scrubbed by the SASE gateway. So the purple line here basically indicates that the subscribers, that the employees' intranet traffic is scrubbed by the SASE gateway, and then sent towards the intranet data center. Again, over SD-WAN or SD-WAN Lite. The traffic is brought in, from the Acme client to the SASE gateway using SD-WAN Lite, and again, traffic is carried from the SASE gateway to the enterprise data center, again using SD-WAN or SD-WAN Lite. Now, the user basically might go to like a SaaS service like Gmail, Office 365, Box, or SharePoint. And definitely all of this traffic again is scrubbed based on whatever the enterprise has configured, for the SaaS service. And in this day and age, all employees basically go to internet destination. Again, again, so all of that traffic again is scrubbed by the SASE gateway. And now, what happens is what would happen if this person were to travel to a different country, which is a few continents away. So people do basically travel for attending conferences or for vacation, but we are always working no matter where we go. So in this particular case, the employee of Acme basically goes to Hong Kong. And now what happens is that, as I said, Acme was predominantly a US-based corporation. So what can happen potentially is that when this person wants to work and he needs to basically do when he wants to he has got a managed laptop and he needs to upload some traffic to his intranet, then what can happen? One potential is that basically this SASE client attaches to a POP within the United States. Now, this particular traffic is going to traverse several basically transit internet service providers, which are not going to give you any kind of a SLA. Now, a lot of so this one, basically, so this is how his intranet traffic. The purple line indicates how his intranet traffic would basically traverse several basically transit service providers, which do not provide any kind of a guarantee for SLA, and then the traffic is scrubbed by a SASE gateway within a US POP and then sent towards the enterprise headquarters. And then what happens is that again, based on the risk appetite or the policies which are enforced by enterprise, they might want that all the users' traffic, no matter what, when it goes to SaaS applications, it all needs to be scrubbed by the SASE gateway. So here what happens is that the user is going to, for example, Office 365. So all of his Office 365 traffic is basically backhauled all the way from Hong Kong, all the way to a POP within the United States. And the same thing could happen with Zoom, the same thing could happen with WebEx, the same thing could happen with RingCentral, Hangout, Teams, everything. So this will lead to very, very poor experience. So here what is happening is all the traffic of the user is backhauled from Hong Kong all the way to United States. And then basically the same thing could happen even if he goes to internet, that the same, basically all of that traffic again could be backhauled. So this would lead to a very, very poor experience. So instead, what a good SASE solution would do is would automatically deploy like the tenant Acme on the Hong Kong POP. And then basically it would make sure that the user basically attaches to a optimal SASE gateway in the Hong Kong location. And now what will happen is that all his traffic is getting scrubbed by a SASE gateway in the Hong Kong POP. And as you can see, that what would happen is that it is also important that the traffic is carried from the Hong Kong POP to basically the US POP and his intranet traffic and to the enterprise's data center using a very, very sophisticated middleman technology, which always takes into consideration the best end-to-end SLA and something which gives the best application performance for the user. So it is important that basically the SASE gateway, somehow they incorporate some kind of a very sophisticated middleman technology. And now the traffic is basically carried from is first of all optimally carried from the Hong Kong POP, perhaps through a Japan POP and the US POP, or it can go directly from the Hong Kong POP to the US POP, whichever of the two offers the best end-to-end SLA. And then it is basically, again, from the US POP, again, it can be delivered to the enterprise's headquarters, again, over SD-WAN or SD-WAN Lite. And now, basically, all his SaaS services, all traffic which is basically going to SaaS services like like Box, Salesforce, Teams, WebEx, all of this is now getting scrubbed by by the gateway in Hong Kong. So this will lead to very good user experience because you are basically processing all of this everything at the right gateway. And definitely all his internet traffic also, which is not shown, also is getting processed by the Hong Kong POP. So it is very important that the traffic is getting processed by a gateway which is proximal and optimal, basically, and which is least loaded. Now what happens is that definitely no basically SASE provider can plan for something which is unforeseen, So basically, what can happen is that because for whatever reason, there is a lot of traffic, basically in the Hong Kong region, or there are failures, Basically, you can have failures of switches and routers, or SASE servers, SASE gateways. So you cannot basically plan for everything. And if you were to basically replicate all of that and have a lot of unused capacity, then the cost of the SASE service is going to be increased, and all of the cost is going to be passed down to the subscribers. So what happens is that you definitely want to basically accommodate for a certain amount of failures, but you cannot plan for everything. So now what happens if there are failures or there is basically a high surge of traffic in the Hong Kong location, then a good SASE solution would automatically bring up a SASE gateway in the nearest cloud service provider, which is in the Hong Kong region, and then any new subscribers, would basically their traffic would now get processed by this SASE gateway, which was dynamically instantiated within a cloud service provider, which was very proximal to Hong Kong. And now in this particular case, a new ACME employee, he gets attached to a SASE gateway in Azure or GCP or AWS, and then his traffic is basically scrubbed by that. And so all is basically internet, intranet, as well as traffic to SaaS services, again, is basically processed by SASE gateway, which is least loaded and optimal. So in summary, it is important that you have a very elastic SASE fabric, and then you do uniform enforcement of the policy. What that means is whether the person is in the United States or whether he's travel to Kazakhstan or whether he's travel to Hong Kong, no matter what, that basically the policies of the corporation are basically enforced. And then basically, definitely we need to process the traffic on the most optimal node. And also that we want to offer a single pane of management. It's highly important. Like what happens that if you have a SASE solution which is stitched together by disparate acquisitions, then you're going to basically switch from one. You'll be looking at one management tool for security, and a different management tool for SD-WAN, and a third for DLP. So all of that will again lead to poor experience. Now this one, so what happens is that definitely, so there are various solutions, various ways where a user can connect to a SASE cloud. So a branch, basically, there is a branch where there are several employees basically working. When they subscribe to a SASE solution, then definitely there is an appliance at a branch. But then there are also times, in this, especially in this COVID times, when many of us are working from home. So what happens is that what we have seen is that that many enterprises, they are deploying appliances at the houses of the executives, So what that does is basically, so it provides you multiple access circuits. So basically you can have like a broadband connectivity as well as 5G or LTE. And then secondly, different kinds of traffic is sent automatically over different underlay transport paths. And then definitely prioritization of traffic is important. So at our houses, we have our family members, basically they are also looking at YouTube, and they're going to Netflix and Amazon Prime. So definitely that needs to take a backseat versus intranet traffic or business traffic, which is going to SaaS application. So this is where basically appliance-based solution comes in very handy. And definitely the appliance-based solution needs to ensure that only relevant traffic is sent, which is applicable to the employees and to any kind of a big data analytics. And something which is basically not relevant to the company is not basically sent to the company analytics for privacy reasons. So I'm going to skip the next slide in the interest of time. Now, the thing is, so again, what this shows you is basically what are the various components of a SASE. Again, like a SASE solution, one is definitely in the middle you see like a blue cloud which represents several SASE gateways which comprise the SASE cloud. And then what you see are basically either SASE clients which are basically deployed on laptops or mobile, and then at branches you have again routers. And definitely any SASE solution should also support BYOD. So people will always be using, for one reason or the other, they would be using basically their family members' phones or laptops in case of exigency. And that may not have basically any kind of a client or pack file or say installed on it. But despite, even if that is the case, all of the users' traffic has to be scrubbed. If the employee goes to acme.salesforce.com or acme.gmail.com, all his traffic needs to be scrubbed by the SASE gateway. So a SASE solution must provide that as well. So here basically, so any SASE solution basically should provide a zero trust network access. And it should provide basically, definitely it needs to provide two kinds of important services. One is the secure private access and secure internet access. So secure internet access refers to basically when the employee goes to basically internet destination or SaaS destination, then we want to scrub the traffic, all of the users' traffic. But then every basically enterprise such as Acme would have certain applications, web apps, which are private to Acme. And in this day and age where people are increasingly moving to cloud, what happens is that that particular application on one day could be running within a private data center, and on a different day it could be running in GCP or Azure or AWS. So basically, so all of the users' traffic basically to private application again needs to be scrubbed. So, and all of this needs to be done based on the user's role, device posture, whether it's authenticated, whether it basically has the right OS patches, all of these things. So any SASE solution should be able to provide different access, different types of access to different users. So let me just go over a few of them.
Well, so if I may, sir.
Yes, go ahead, please.
So in the secure private access, clearly what we want to demonstrate here is that the user gets access to the workflows that he's supposed to get to. So in this case, he's supposed to get to his marketing app. But when he tries to upload something that is malicious to the marketing app or tries to download something malicious from the marketing app, it actually then gets blocked by the actual security SASE service itself. And in this way, we're able to actually protect the application as well as protect the user from having malicious stuff. But if the user were to try to do something out of normal for the behavior, he would also be blocked. So in this case, we're going through and he's going to try and access the engineering department. And instead of being able to access the engineering department, the compliance is that you're not allowed to do that. This will happen whether or not it is secure private access or whether it is secure internet access. The same sort of things apply. You don't want them necessarily going and putting things out where they're not supposed to. So he has internet access to his SaaS provider to do what he needs to do for work. But yet, when he's trying to go to a social media platform, we have said that that is not appropriate to upload that same information or whatever the information is from the security posture, and then we block it. Now, one of the things that people always ask is, where can this ubiquitous security and protection arise and be formulated from? And the beauty of the SASE framework is that this needs to be modular. You need to be able to have a thin client that is doing the minimum viable security that you need at that site, but also then have a thick cloud or a thick environment to do the rest of it. And it needs to be able to scale to where you have an actual thick client at the site. And so as we can see here, the cloud is doing all kinds of this data scrubbing and security functions throughout this whole set. But we can also take that and we can put this so that we have the full set of stuff either in the data center, or we can have the full set of stuff right on the appliance. And even when you have a SASE client, a true SASE client still has minimal viable components to the SASE client that allows it, one, to be a policy enforcement point. Because what we're going to talk about next is that the traffic needs to be optimally steered to the optimal secure path. And in some cases, some of the information may need to go directly to a SaaS provider or to an internet in the case of information that the enterprise has deemed safe. This does not necessarily mean that we're opening up a hole. It is not a firewall hole. It's not a vulnerability open. What this means is that there was a SASE enforcement point from the SASE client that applied the enterprise's policy that allowed the traffic to go that way. What this also allows for is that some of the traffic can be steered back through the security cloud. But this also can be done based upon a static policy that says, hey, for my Zoom and Zoom calls, I need you to go to the SaaS provider directly through the DIA. And maybe for YouTube that you're watching or Netflix, I'm going to go that way because I trust that security posture. But it also allows for the behavioral analysis that says, hey, something's going on with Zoom or something's going on with the Netflix environment. Now I have an enforcement point where I can actually redirect and say, okay, for this next flow, or maybe this actor is doing something unusual and I want to take a closer look at his traffic, that I actually bring the traffic back through the SASE cloud to take a larger look. So this can be done, like I said, from the client. It can be done from the appliance that's out there. And one of the things that Apurva really talked about is that we have to do this in an optimal path, right? We need to make sure that when the user is trying to get to his SASE service, that he has the best and most secure path. And that can be done based upon SLA, that can be done based upon regionality, that can be done based upon many different factors. And it could even be done that you want to actually segregate the traffic from, say, executives versus regular employees, employees versus customers, right? We need to be able to do this in a manner that is going to apply the policy based upon different attributes and possibly based upon different applications. And that requires a application-aware, policy-driven networking construct. And so SD-WAN fits in there perfectly. SD-WAN light type connections that Apurva talked to could do this, but clearly SD-WAN is best positioned for providing this type of connectivity. So a SASE
so Neil, I wanted to add something here that basically in this particular case, what happens is that that from a branch to the SASE gateway, again, you can do SD-WAN, and again from the SASE gateway to the enterprise data center, again, you can do SD-WAN or SD-WAN Lite. And then definitely, basically, like the few other thing is that you also want to support, basically, even if somebody is coming from behind a SASE client, that we do support that some of the prefixes or some of the subnets are reachable through one gateway and some other ones are reachable through some other gateway. And then there's basically the SASE client should be able to basically should do monitoring of the tunnels and failover and all of that. If one of the basically connectivity to one of the gateway goes down, then it should switch over the traffic to a different tunnel. So all of that needs to be supported. So there has to be a SD-WAN Lite capability between the SASE client and the SASE gateway. And then finally,
I agree, Apurva, because even when it comes to connectivity, right, almost every one of our laptops and almost every one of our phones now comes with multiple radios or multiple connections, right? You have your wired Ethernet connection at home, you have your Wi-Fi, you might have a cellular card into it. So we have to build into this product, and a proper SASE would be able to take advantage of all of this connectivity, whether that's wired or wireless, and be able to arbitrage to this, right? So I think that this whole set here is exactly what we need. And I think once you take this all together, we now have a good solution for SASE. And I think in interest of time and getting to the users, the audience's questions, I think we'll let them read the requirements for a good SASE solution. But Apurva put together a very comprehensive list here of things that you should consider when dealing with a SASE service.
Great. Thank you, Neil, and thank you, Apurva. That's a great overview. So remind you to ask questions in the Ask a Question box. We've got quite a few that have come in. We've got about five minutes or so to answer as many of these as we can. So one of the questions that's come in is, how is SASE different than some of the current offerings from cloud providers that are out there today? What are the differences, or are there any differences?
So yeah,
Neil or Apurva.
So SASE basically, one other thing is that, so right now, so you have like a lot of CASB providers, or you have a lot of SD-WAN providers. So as we said, right, like SASE is a perfect marriage, between basically SD-WAN and basically and security for SaaS services. So so it is important, that basically any SASE solution optimally takes the traffic, basically from a SASE client to a SASE gateway, again from a SASE gateway to the enterprise data centers or the cloud service providers. And definitely it provides all kinds of basically, definitely once the traffic comes, security is very important. And so it should still do complete DLP, CASB, ZTN, and all of that. And then it should also provide options, basically that for the SASE client to somehow certain traffic can basically be split tunnel, and based on the comfort level of the enterprise.
Fantastic. Thank you, Apurva. Okay, next question is, what can I keep on premises for security when running SASE in the cloud? Neil, can you take that?
Yes, Mike. So as Apurva said, one of the differentiations between current cloud offerings is just this idea of flexibility, right? So a lot of the current offerings that are security-based, they want to do it all for the most part, or they'll allow you to do portions of it, but kind of what they allow you to do is limited. So realistically, in a SASE service, any type of security that the enterprise wants to do on premise, as long as they have enough compute, enough storage and processing and bandwidth, you could actually allow that to be there. And the SASE service will take care of the policy and the ubiquitous and uniform policy enforcement and the security chain functioning to make sure that what you didn't do at the premise and what you need to do in a cloud service actually gets done. So the SASE service would actually allow you to scale and move these workloads as the enterprise deems fit, and that could be based upon different policies.
Fantastic. Thank you, Neil. The next question is, this is an interesting one, just around the SASE orchestrator and what might one expect in terms of how that relates to like an SD-WAN controller, and what's the relationship there?
Okay, so basically, definitely a good SASE solution should provide a single pane of management for both SD-WAN as well as all the security services, which is CASB, DLP, ZTNA, Secure Web Gateway, RBI, everything. Then the second one is definitely that in terms of the user plane components, definitely it is that in order that there is no replication of functions which can introduce latency and all of that, that it is also important that the same entity, basically is doing traffic steering as well as all the security processing. Because if you are if everybody is going to crack open the packet 3 times, if 4, if DLP, then SD-WAN, Secure Web Gateway, if all of these are independent functions and they're basically going to open up the packet multiple times and do the same thing over and over again, that's going to lead to poor performance and higher latency. So it's important that basically it's a single pane of management and a single pass architecture.
Fantastic. Thank you. Apurva, great questions keep flowing in. This next one, Neil, is for you. Does SASE provide or support slicing, segmentation down to layer 7 application features to isolate traffic for specific functions and services, or just down to the application access rate? So great question, Neil. Maybe you can take that.
So a true SASE service is completely multi-tenant. And what that means is it has to provide complete segregation and segmentation of all the traffic for every security flow based upon the policies that the enterprise has written to execute their security posture. So SASE services are not tangential, or they're not orthogonal to network slicing. They actually need to incorporate network slicing. Now, network slicing in itself doesn't necessarily mean that you're going to get all of the performance and the optimal security pathing for this, and it doesn't necessarily ensure that all the individual security functions are there. But SASE definitely can incorporate slicing either down to the application level or not, and it will use a zero trust framework to actually apply more than just rights. It's actually going to apply context. It's going to apply situational and behavioral attributes to actually determine whether or not the flow should actually be authorized and authenticated to flow across the SASE service.
Okay, great. Thank you, Neil. And this next question, Apurva, maybe you can take this. Question is, does SASE negate the need for SD-WAN hubs? If so, how are non-internet underlays supported at the SASE gateways? So a lot packed into that question, Apurva.
Yeah. So the SASE basically does not negate basically SD-WAN gateway. And the thing is, even if you have a non-internet path, basically, like for example, a good SASE solution will offer provide connectivity to direct connect or express route and all of that. And basically, it can and you can have SASE solutions which are specific. It can even provide basically connectivity to MPLS, to MPLS providers which belongs to enterprises. And that particular underlay could be used just for that underlay, just for that specific tenant. So basically, SASE solution doesn't. And the SD-WAN gateways can coexist in the same appliance or the same SASE gateway.
Thank you, Apurva. Well, thank you very much, Apurva and Neil. This has been a great presentation, a lot of fantastic questions and phenomenal content. And I'd like to remind everybody this has been recorded. You can watch this on demand shortly following this live broadcast. And of course, you can always download all of the attachments, the slides, and a great industry analyst white paper on SASE. Thank you again, Apurva, and thank you, Neil.
Thank you all.
Thank you, Mike.